to another section of this video. Today we are going to be handling gas laws. So we all know that we have three states of matter, and gas is one of the states of matter. So today we'll be looking at those laws governing gases. But first of all, we have to know that there are two types of gas. We have what we call the ideal gas and the real gas. Okay, so for the ideal gas, there are laws governing these gases. Okay, so those laws governing these gases are what we're going to be looking at today. So we also have laws governing the real gas. So in today we'll be looking at the laws governing the ideal gas. Okay, so most of us have heard about some of these laws, like the Boyle's Law, the Charles Law, and the rest of them. So today we'll be looking at those laws and how these laws are important for these gases. Okay, so the first law we'll be looking at is the Boyle's Law. Okay, most of us now have heard about this Boyle's Law. This Boyle's Law is actually a law that governs gases, and it states that the volume of a fixed mass of any gas is inversely proportional to the pressure, provided that the temperature or the absolute temperature is kept constant, or provided that the absolute temperature is kept constant. So mathematically, this Boyle's Law can be represented like this. So we can go further to actually prove this formula. So we have that V is equal to, we introduce a constant K over P. So making this K subject, we have that K is equal to PV. So this is the mathematical expression for the Boyle's Law. So from this, we can see that if this constant is equal to this, taking the first constant, we can have that this, if we assume that K1 is the first constant, this K1 will be equal to this. And if we assume that the K2 is equal to P2 V2. So when we equate the two constants, we will arrive at an equation or a formula which is very, very important in this law, which is P1 V1 is equal to P2 V2. So this is very important in some of the calculations you're going to encounter in the Boyle's Law. But one thing is constant. Always know that the Boyle's Law is comparing volume and pressure, keeping temperature constant. So please make sure that you understand that this P1 V1 actually talking about the initial pressure and the initial volume of that gas, while P2 and V2 represents the final pressure and the final volume of the gas. Alright, now take a look at this question involving the Boyle's Law. So how would you know that the question, you can apply a Boyle's Law to a question? You must always see that the temperature is constant or it is the same throughout the process. So look at this question now. A sample of air occupies a volume. Take note of the volume. This is the V1. Okay? At 20 degrees C. This could be T1, but we are not sure until we are sure that the temperature is the same. If the temperature is the same throughout the question, then the temperature is constant. There's no need to use it. So so at 20 degrees C, and this is the temperature. Let me underline this also. Now, and 1 bar. Already, they have converted the bar to kilopascal. So we can be able to use. You can solve this question with anyone. You can either solve with the bar or with the kilopascal. At the end of the day, your final pressure, what you are looking for, can still be in kilopascal, it can still be in bar, depending on the one you want to use to solve. But just know that 1 bar is equal to 100 kilopascal. Okay? So now, this is the what? The pressure, initial pressure of the gas. Okay? And I said, what will be the pressure of this gas if it is transferred to a 2-liter? This is the what? The second volume. Remember, this is the first volume. This is the second volume. This is the V1. this is the V2, but they are not in the same unit, so you have to convert it to be in the same unit. Okay, you can convert it to be in ml, or liter. If it's a multiple choice question, then you have to look at the option. If it's a question that involves A, B, C, the options. If the options are in, okay, for example, we're looking for pressure, so you don't have to you have to convert it. To get the answer to this question, you must convert these things to be the same, either in ml or in ml, or liter. You will still get the same answer. Okay, so that's it. At the same, look at this statement, at the same temperature. So it means that the temperature before and after is the same. So because of that, we are going to apply Boyle's law. That is the reason why we are applying Boyle's law. Most of the times they might say if the temperature is kept constant. Whether it's kept constant or is the same throughout the process, it is still the same thing. So you apply the Boyle's law. So you don't have any business with this other temperature, you ignore. So from this question, we know that the Boyle's law is this. From what I told you, the Boyle's law is this. This is the Boyle's law. So you have to make sure that all the parameters are intact, then before you can be able to solve. So how do you get the parameter? The P1 has been given. P1 has been given to you as 1 bar, okay, which is the same thing as 100 kilopascal. Okay, V1 has been given to you as 450 ml, right? Yes. So permit me is my choice. I can decide to work with what, ml all through, or liter all through. So since I have this in ml and I have the V2 in liters, I will convert. Okay, but let's leave that for now. We'll convert it in the next. We'll do that. Now we have all the parameters P1, and we are looking for the P2. Recall what we are doing. The P2 is what we are looking for. We are looking for this. So remember, we have our P1, our V1, our V2. We are looking for P2. So we are going to make P2 subject of formula and then calculate the P2, knowing fully well that we have everything in place. Recall that the P1 is 1 bar. Okay? We can either use it in bar or in kilopascal to solve this question. V1 is 450 ml. So we have to make the V1 and the V2 to look alike. So I converted the V2 to ml. What did I do? I multiplied by 1000. Okay? If you want to convert liter to milliliter, always multiply the liter with 1000. The moment you multiply 1000, you have converted to what? ml. So applying our Boyle's law and making the P2 subject of formula, recall that we have that P1 V1 is equal to P2 V2. So making the P2 subject of formula, we have that P2 is equal to P1 V1 all over V2. I hope you know how to make something subject of formula. Okay? If you're looking for this, you divide both sides by what is close to that, which is what? V2. So if you have something like in mass, if you have 10, it's equal to 2a. If you're looking for a becomes 10 over 2. You divide both sides by 2. Okay? So you can actually do that and then get the a, but that's not what we are here. So look at this. We have P2 is equal to this. So the next thing is to what? Is substitute. So how do you substitute? P1 is 1 bar. Like I've told you, you can either use any of them. If it's a multiple choice and the options are in bar, of which they can be in bar, okay, it can be in bar, we're looking for P2. Since we're looking for P2, if the options are in bar, then we're going to make use of 1 bar. But if the options are in kilopascal, we make use of kilopascal. If it's in pascal, we can also make use of it in pascal. So let's assume that we are looking for this P2 in bar. Okay? So we're going to have 1 times V1. V1 is what? 450. Okay? Let's work with units. 1 bar times 450 ml all over V2, which is what? 2000 ml. Okay? ml will cancel ml. Okay? What is left is bar. So like I've told you, since we are looking for the answer in bar, I am working with bar. If I'm looking for an answer in kilopascal, I'll work with kilopascal. If it's in pascal, I'll convert this. Remember, this kilopascal, to convert it to pascal, anything kilo means 1000. So multiply the thing by 1000, you get it in pascal. So in bar, we have this. So if you solve this, you have 2.25 bar. Okay, so this is the answer in bar. But if the option says otherwise, you can still convert this bar to any unit of your choice, depending on the question. So go back, you have to go back to the video on SI unit to know more about how to convert from bar to kilopascal or from kilopascal to pascal.